Hi everyone, today we're going to start 10.3, which is apply properties of chords. A chord. A chord is a segment whose endpoints lie on the circle. So this here is our chord. It goes from one endpoint of a circle to another. So here's some definitions or properties of chords. So because the endpoints lie on the circle, any chord divides the circle into two arcs. A diameter divides the circle into two semicircles. And any other chord divides the circle into a major arc and a minor arc. So let's kind of repeat what I just read to you. So any chord, such as this one here, will split up the circle into two arcs, a minor arc and then this blue one, which is a major arc. If we go through the diameter, we then know that we created two semicircles, as you see here in blue and in red. Bisecting arcs. If arc XY is congruent to arc YZ, so we're saying if this arc is the same measure as this arc, they are congruent, then point Y, which is right here, and any line segment or ray that contains Y would bisect the large arc XYZ. So that means that CY here, this segment, is going to bisect our large arc. For Chords theorem, in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So what's important here is the statement, which just says that arc AB and CD are congruent if these two segments are congruent. Let's scroll down here. If one chord is a perpendicular bisector of another chord, then the first chord is a diameter. So what's important, I would write down this here and kind of sketch out this picture. So if we know that SQ is a perpendicular bisector of TR, so perpendicular creates a 90-degree angle, bisector means it cuts it in half, then we know that QS is a diameter of the circle. If the diameter of a circle is a perpendicular bisector to a chord, then the diameter bisects the chord and its arc. So what it's saying here is that if we know that EG is the diameter and EG is perpendicular to DF, then that means that HD and HF are congruent, and then the arcs GD and FG are also congruent. In the same circle, or in congruent circles, two chords are congruent if and only if they are equidistant from the center. Equidistant just means the same distance. So what's important here is what I have starred. So if AB, this entire chord, and CD, this entire chord, they are congruent if and only if we know that EF and EG are the same distance away from the center, or that they're congruent. Use the diagram of circle D. So if the measure of arc AB is 110, so AB would be this arc right here. If this is 110 degrees, we want to find the measure of arc BC. Well, if we look at our diagram, we see that these two chords are congruent. So since the two chords are congruent, that means that their arcs are congruent. So BC then would be 110 degrees. Part B, if the measure of angle arc C now is equal to 150 degrees, so now we're going to say that this is 150 degrees, we want to find the measure, let's try that again. AC. All right, so this arc AC is 150 degrees. I want to figure out what is the measure of arc AB. And we know that arc AB is here, and I'll call that X. Well, once again, by looking at our chords, we notice that these two chords are congruent, which means whatever measure we figure out for AB is going to be the same as BC. So I could also call this X. Now we have a circle. What is the measure of a circle? Well, we know it's 360 degrees, which means if I add up all of the arc measures, they equal 360 degrees. So let's write that out. So I know that X plus 150 is equal to 360. Let's combine our like terms. X plus X is 2X plus 150 is equal to 360. Subtract 150, we end up getting that 2X is equal to 210, meaning that X is equal to 105. So back to our question, what was the measure of arc AB? It's 105 degrees. Use congruent chords to find an arc measure. Use the diagram of circle E to find the length of AC. Tell what theorem you used. All right, so AC is this length here. And we notice that we have a perpendicular 90-degree angle here. So if this measure here is 7, and we notice that this is a diameter because it goes through point E, that means that the diameter is a perpendicular bisector of that chord AC. So if FA is 7, we also know that FC is 7. So what is the length of AC? Well, we just add those up, and it would be 14. Find the measure of the indicated arc in the diagram. We're going to start with CD. Well, if I look at CD, we're looking at this arc here. But I don't really know much other than that BD is a diameter. We know that it is perpendicular to this chord, meaning that these two segments of the chord are congruent. Since those two segments are congruent, that means that these arcs are also congruent. So before I can figure out 3, 4, or 5, I need to set these equations equal to each other. So I get 9x is equal to 80 minus x. Subtract 80 from each side. Or I'm sorry, I don't want to subtract 80. I'm going to add x to each side. So I get 10x is equal to 80. Divide by 10, I get that x is equal to 8. All right, so now that I know that x is equal to 8, I can now plug x back into my equation here. And I know that 9 times 8 is 72. Now, since CD is equal to 72, I also know that DE is equal to 72 because those arcs are congruent. Lastly, I need to figure out what is the measure of arc CE. And so C is actually this one here. I highlighted the wrong arc before. So CE, we know it's a minor arc, so that's why I know it has to be the smaller one. And so if I want to figure out the length of arc CE, I'm just going to add 72 and 72. And we get 144. Next, in the diagram of circle C, we know that QR is equal to ST, which is equal to 16. And so that's here. I see that QR is 16 and ST is 16. We want to find the length of CU. So this here is what I'm looking for. Well, since we know that the chords QR and ST are congruent, it means that they're the same distance away from point C, which means that these segments are also congruent. So I'm going to set those equations equal to each other. 2x is equal to 5x minus 9. And when we do algebra, we end up getting that x is equal to 3. So it didn't ask for x though. I need to figure out what is the length of CU. So I'm going to plug in x in that equation, and I end up getting that CU is equal to 6. Suppose ST is equal to 32, so let's draw that out. ST is equal to 32. And CU and CV, they're the same, and they equal 12. This equals 12. We want to find the given lengths. So first off, what is the length of QR? Well, if QR and ST are the same distance away from C, that means that they're congruent. So that means that QR is also going to equal 32. Next, QU. Well, if QU bisects the chord QR, so if the entire chord here is 32, that means that QU would be half of 32, which is 16. Find the measure of the given arc or chord. Let's look at the measure of arc BC. So BC is here. If you look at the triangle, we notice that this segment and this segment are congruent, those chords, meaning that their arcs are also congruent. So that would make this arc, we'll call it X, and this arc here would also be X. What is the measure of a circle? Well, just like before, we know it's 360. So I need to add up all of these arcs, set them equal to 360. So X plus X plus 116 is equal to 360. Combine like terms, 2x plus 116 is equal to 360. So we end up getting that x is equal to 122. Let's look at 2. So we want to figure out what is the measure of arc LM. LM is right here. What do you notice is inside of this circle? Well, we see that it is a square, and by definition, we know that a square has 4 right angles and 4 congruent sides. So all these sides are chords. If all the chords are congruent, what does that mean about all of these arcs, these 4 arcs? It means that they're also congruent. So to figure out what one arc is, x, all I'm going to do is take 360, divide it by the number of arcs, and I have 1, 2, 3, 4. These would all be x. And I'm going to do 360 divided by 4. And we end up getting 90. So x then is equal to 90. And our last one, QS. So QS is here. If you look at your diagram, we notice that we have a diameter here that is perpendicular to this chord, meaning it's a perpendicular bisector. So if this segment is 11, that means that this segment is also 11. So what is the length of QS? It would be 22. Find the value of x. If I look at number 7 here, once again, I see that I have a diameter, it goes to the center, and it is perpendicular to this chord, meaning that those two segments are congruent. So I'm going to set these equal to each other. 3x plus 16 is equal to 12x plus 7. I end up getting, if I simplify this, 9x is equal to 9, and x then is equal to 1. And our last problem of the day. So W is the center of the circle, and I have 2 chords, ST and VU. I notice that they are the same distance away from W, meaning that these 2 chords are congruent. So ST and VU are the same length, or I'm sorry, they're congruent, the same length. So 6x minus 5 is equal to 13 plus 4x. And when I solve here, I end up getting, let's say 2x is equal to 18. Divide by 2x then is equal to 9.